Okay, here's a sample problem that, again, helps us get a better understanding of what couples are all about and some of the ways that we can manipulate systems relative to couples. And it essentially says, hey, let's calculate the moment um, that's created by these couples. You can see that there's two equal and opposite forces separated by a distance. Let's come up with a moment that is created on this system, whatever it is, piping apparatus, relative to these two couples here. Now, it'll tell you that there's a couple ways that you can do it, and we'll take a look at each one of these. The first one is basically by adding um, some forces at a point to actually help us create additional couples or one additional couple. And the second one is to choose some point, such as what they're saying in here is D. And what we'll do there is basically just create or calculate the moment about point D, much like what we've already done in this chapter. So anyway, the first one, what they're going to do here is they're going to attach up there at A two equal and opposite 20-pound forces. Now consider for a moment what this does. The two equal and opposite 20-pound forces at A by themselves make no change to this system. Okay? I mean, if this system was floating around in space, those 20 pounds acting sort of to the right and 20 pounds sort of acting back to the left, it makes no change in that system. That system is not being pulled one way or the other any more or less than the original system was. However, what that does is the 20-pound force to the right, okay, is now or can be now considered part of a couple with the 20-pound force over there at E, because they're two equal and opposite forces going in the, separated by a distance. The other additional 20-pound force that we added up there at A, sort of acting to the left, it creates a couple with the 20-pound force down there at D. Okay? So again, this sort of what this does is it sort of helps us because now we're putting couples around, if you will, the different orthogonal axis systems, the X, the Y, the Z. Okay? Excuse me, sort of went past it there. So what it says here is you have a moment, from a couple about the in the X or about the X direction. That couple would be the 30-pound forces separated by the 18 inches, 9 plus 9, 18 inches. Now again, the way to look at that is that sort of rotating or causing rotation. And the plane that that's in is actually the Z plane, okay? And if we, again, sort of, took a look at, how that's creating a moment, the vector would actually be pointing out of that plane into the x-axis, and then actually it's going the other way. So there you'll see them have negative 540 inch-pounds. So again, stick your hand almost like it's, with your fingers pointing on a top 30, and curl your fingers and your thumb will point sort of in the negative x direction. All right. As far as the y direction goes, you'll see they say 20 pounds times 12 inches. Okay. And again, this 20-pound couple, is actually laying up there, sort of laying in the x plane. All right. And so if you, again, sort of took your fingers and curled them like they're pointing next to E, you can see that that would actually create a vector because your thumb is pointing upwards. So they say, 20 times 12 plus 240 inch-pounds. The 20 times 9 is really down there from A to D, or excuse me, yeah, A to D, all right? And again, that's sort of like in the Y plane, if you will, that's existing in the Y plane. But if you curl, again, your fingers at A, pointing, sort of left at A and curl them, okay, you've got your thumb pointing down the Z-axis, and that would be 20 times 9, 180 inch-pounds. So again, the moment produced by these various couples, and again, the addition of those two 20-pound forces, again at the beginning, makes no difference to the system. So you can see the moment in the I, J, and K directions. Now, alternatively, what they say you could do is you could just choose a point like point D. D is a nice point to choose because when you choose a point like D, the 20 pounds and the 30 pounds down there at D just sort of go away because there is no distance. And then really what you're going to do is just calculate a moment. You're going to calculate a moment about D. And what you have to do there is, again, what we've done in the past, which is look at a position vector R times a force. So if you're down there and you put your finger down there at point D and you look up at that 30 pounds, you're going to say, hey, that's all in the Y direction, okay? And that's going positive Y, and that's 18 inches. So the position vector from, if you stick your finger down there at D and say, how far do I have to go, basically, and in what direction do I have to go, basically, to get to the 30-pound vector that's up there at C, you'd say I'd have to go 18 inches, and it's straight up the Y-axis. So we're going to call that 18J. That cross product would be that R vector multiplied by the force, 30. And again, if you look at 30, you'd say, hey, is there any X component to that? And you'd say, no, there's not. Okay, the only thing that there's no Y component. The only thing that you have is a Z or a K component, and it's going opposite of what positive K is. So it's heading down towards the origin, and so that's negative 30 pounds. Again, you're taking moments about D, so let's look at the 20-pound force. Again, what is the, basically the R vector? Well, let's break it up into I, J, K. Okay. As far as the I goes, there is none because both D and E are sort of still at the origin when you consider the I direction. When you look at the J direction, or up, we have to go up 9 inches, so that's positive 9 inches J. And we have to go towards the origin in the Z direction, or the K direction, and as we move that way, we'd have to go 12, but that's negative because it's back towards the origin. So my position vector R can be expressed as 9J minus 12K. The 20 pounds acts in the X direction, but it acts negative X, so we'll give it a negative sign, and again, I is what we call X. So then I've got my two vectors there, and again, I can just do the determinant system there, and you come up with the exact same moment as we had the first time around, or the first way that we chose to do this on the previous slide.